Good afternoon, class. Today's subject is biomimicry. Can any one of you define the term biomimicry?
Biomimicry is defined as the art and science of imitating nature's ideas, in order to solve human problems.
That's correct. And for this report, the ideas and strategies are derived from the Triticana gigas life mechanism and are applied in Al Manzil Cafe, located in Dubai. Now let's have a look at a video for further explanation about the clam. Triticana clam is the largest living bivalve mollusk, is very famous for its features, functions and environmental behavior. Giant clams occupy coral reef habitats, typically within 20 meters of the surface. This clam are found in shallow lagoons and reef flats. Tridacna gigas are found throughout the tropical Indo-Pacific Oceanic region, Nicobar Islands, Fiji, China Seas and the Australia northern coasts. The Tridacna gigas clam consists of visible and invisible body parts. When the clam shell opens, only the mantle, the shell and the siphons can be viewed. The rest of the body parts are not exposed and cannot be viewed. That was a brief presentation about the anatomy. I will focus on the visible body parts. Under the observable body parts we see clam shell, the siphons and the mantle tissue. The Triticana clam consists of two shells. Between these two shells is a tissue-like structure called the mantle. Did you also know that the clam reacts to change of light around it? Here is a video showing how a clam reacts under different intensities of light. The mantle tissue acts as solar collector. During the day the clams spread out their mantle tissue to absorb the maximum sunlight. This light entering the mantle is either absorbed by the zooxanthella to photosynthesize or reflected back by the iridophore cells to protect the clam from excessive UV radiation. Color and pattern of the Triticana mantle depends upon the viewing or lighting angle. The mantle consists of three structures. They are iridophore cells, non-photosynthetic pigments, and photosynthetic pigments. Iridophore cells are distributed on the outer layer of the mantle tissue, in order to cover and protect the zooxanthella colony. The iridophore cells have three main functions. Firstly, these reflective cells protect the clam's mantle tissue by acting as sunscreen, reflecting back excessive UV radiation. Secondly, these cells are used in redirecting the solar photons deep down the mantle tissue in order to provide uniform lighting for the algae to supply the clam with photosynthesis. Thirdly and finally, the iridophore cells consist of iridocytes. These iridocyte cells distribute only the useful light wavelength, mostly in a cone-like distribution, pointing deeper into the clam's tissue in order to reach the zooxanthella. In Triticana, bulks of zooxanthella are piled on the clam's mantle tissue forming thin sheets. The zooxanthella are formed in pillars and are oriented in the opposite direction. These pigments act as sunscreen and UV shields. They are used to block the excessive amount of UV radiation and eliminate the light that can decrease the photosynthesis process. This type of pigment performs photosynthesis by absorbing the solar energy and converting it to chemical energy to feed the clam. These type of pigments are used to reflect the harmful wavelengths and are also used in. Can you give us a summary about the lessons learned, followed by the presentation of your project?
Good morning. Now I shall sum up the lessons learned followed by my presentation of the Al Manzil Cafe project. Iridophore cells are reflective cells that protect the clam's mantle tissue by acting as a sunscreen, and reflecting back excessive UV radiation. Secondly, these cells are used in redirecting the solar photons deep down the mantle tissue in order to provide uniform lighting for the algae. Thirdly and finally, the iridophore cells consist of iridocytes. These iridocyte cells distribute only the useful light wavelength. Non-photosynthetic pigments. These pigments act as sunscreen and UV shields. They are used to block the excessive amount of UV radiation and eliminate the light that can decrease the photosynthesis process. This type of pigment performs photosynthesis by absorbing the solar energy and converting it to chemical energy to feed the clam. The diagram shows the lessons derived from the natural concept and the strategies implemented form this lessons. The main aim for this research is to implement the lessons learned from the above natural concept into an existing case study. For this research, my case study is located in Dubai. Dubai is located within the northern desert belt, with a tropical desert climate. Dubai summers are very hot, humid and sunny. During the day the average high reaches to 40 degrees Celsius. Winter days are short and warm with an average temp of 23 degrees Celsius and overnight falls to 14 degrees Celsius. Dubai weather can bring short and irregular rainfall from December to March. The most comfortable climatic condition period in Dubai is between December to March. The highest radiation range takes place in May, June, July and August. In this 4 months the direct radiation and the global horizontal radiation ranges to 1000 Wh/m². During most months of the year the humidity is above the comfort zone. From the graph we can recognize that the humidity rises in morning and falls at 12 noon then rises again. Al Manzil Cafe is located in downtown Dubai and is attached to the existing Al Manzil Hotel. This cafe is located in mid of the town, on a main street, and surrounded by many landmarks such as souks and hotels. The cafe is occupied by both the guest hotel and outsiders. It is occupied through day and night, without any specific peak hours. The west elevation is attached to Al Manzil Hotel. The cafe is oriented towards the east. The east and south elevations face the main street and the pedestrian walk. The east elevation of the cafe is oriented towards the east and is exposed to direct sunlight. This solar stress study shows the amount of radiation received by the zones. The cafe receives 465 W on June 1st at 7 o'clock am on its east-oriented facade, which means there is an excessive amount of solar radiation and heat inside the building. The amount of solar stress differs with the zone orientation, timing and month. This study shows the amount of shading required for the building in order to achieve the thermal comfort inside the building. On June 1st at 7 o'clock am 42% of the east-oriented zone is shaded, which means we need an intensive shading system. The cafe consists of 19 outdoor, 28 indoor, 2 washrooms, a dishwasher area, and a prep area. The whole cafe is 163 meters square, with non-glazed openings of 1.96 by 2.6, there are 2 entrances. One on the south and the other on the east. Some sun studies and calculations were conducted on this case study in the ecotect analysis in order to measure the amount of heat and daylight in this cafe. From these studies we realized that the grid color for the cafe zone turned into yellow and the daylight factor was 7200 lux. This is an indicator of excessive daylight into the zone which results in glare, heat and incorrect light distribution. This excessive daylight resulted from the number of glazed openings, size of glazing, and materials used for the glazing. These factors lead to excessive heat inside the zone, which requires high cooling loads in order to achieve the comfort level. Having done my research about the features of the clam and the analysis of the site, here are 3 strategies which will help in creating a pleasant environment in the cafe. Since the building is oriented towards the east, there is an excessive amount of daylight entering the building. This light entering results in producing heat gain and glare inside the space, which affect the guest visual and thermal comfort. The light shelf will be placed on the windows in order to control the amount of sunlight entering the place, to shade the area near the window and also to reduce the window glare. This shelf is a simple horizontal surface device, installed above the eye level with a high reflectance surface material. The light shelf avoids the direct light entering the space. It redirects the light to the ceiling surface. Since the ceiling surface is made of the reflective material, it will reflect and distribute maximum amount of light in the space. After applying the light shelf to the cafe, the amount of daylight decreased from 88% to 48%. The cafe windows are oriented towards the east, and the window glazing is exposed to an enormous amount of ultraviolet and infrared radiation. According to my ecotech analysis, it's been indicated that the cafe glazing absorbs and transmits a huge amount of heat to the space, which make the space loses its thermal quality. In order to achieve thermal comfort inside this cafe, I decided to use a double glazed window. Double glazed windows will be used in addition to the low E coating. This type of glazing are also known as insulated glazing. Double glazed windows consist of two glazing panes with an air or gas filled between them. This gas is used to reduce the transfer of heat into the building. The double glazed windows have reduced the amount of heat inside the space, which resulted in less monthly cooling required in the zone. The cooling load required was reduced from 54,435,728 watt-hours to 29,377,354 watt-hours. Photovoltaic cells are used to absorb sunlight and convert it to electricity by producing electric field with the help of p-n junction when the two layers comes in contact with each other. This process takes place on top surface of the cell. When the sunlight strikes the PV cell, this electric fields produced provide direction and moment to the light stimulated electrons, which results in flow of current in an electrical load. I added 18 PV cells on the roof. Area of single PV module is 0.9 square meters. PV cells reduce the amount of electrical energy consumed inside the cafe from 385.7 megawatt-hours to 212.135 megawatt-hours. This is the end of my presentation. Thank you.